would like to just take you through a set of slides which talks about the various activities that ISRO does as part of sustainable development, if I can say, conservation, preservation of nature, and various other unique elements which today evening we are talking about. So the topic I am talking about is Eye in the Sky, Earthwatch. Typically, when you look at the space from here, you almost look that there's nothing up there, but when you start looking down from the top, actually this should have been animating, but doesn't seem to be moving. But basically these tracks are showing the polar orbiting satellites which are in the range of 600 to 900 kilometers from the Earth, and they provide some excellent pictures for us. For example, each one of these tracks basically talk about various satellites which we put into the orbit, and Indian remote sensing satellites in the polar orbiting nature is providing some excellent images to the ground, which is being used by the country today in a big way as far as remote sensing data and utilization is concerned. To describe a little bit more about the Eye in the Sky, we have some excellent satellites done, and possibly India is very unique in putting these kind of satellites into space. We have specific satellites for land and water. We have some very unique satellites for very high resolution imaging where you can do mapping. And there are some very unique satellites again, both with respect to Indian constellation as well as the Indo-French constellation, which looks at the ocean in a big way. We have OceanSat-2, the scatterometer, and the Saral Altica, which gives you a lot of interesting information about the ocean. And of course, the weather and climate, also we have a sector where we have some very unique satellites. So we are very clear about what we need to do in space, and these are the kind of satellites which is providing some very unique information, which possibly quickly I'll go through and show you how this is helping India in making various kinds of plans for at least the natural resources development. Typically, these imaging capabilities, when we look at it, are unique. We have the push broom sensor, which basically gives you a sweep of the ground, which provides some excellent data. We have three-dimensional mapping capability, which shows you the Himalayan range. In fact, the Mount Everest can be seen with the peak here. I would have shown you a beautiful animation of this, a three-dimensional animation, but due to lack of time, I am skipping all of that. We have radar imaging satellites which penetrates the clouds and give you some excellent data of the ground, both water and the land. And we have a three-tier imaging capability which gives you wide varieties of data sets, not only of India but of the globe. A typical example of how we are monitoring the land use pattern in the country. You'll be surprised that for the last 14 years, we have some excellent land use, land cover maps prepared for the entire country. As you can see on the left-hand side here, it shows you the land use, land cover right from 2004 until 2017. And you can literally go into a particular taluka or a block and see what has happened in the last 14 years. This is possible from the databases which we have already put out in the public domain. In addition to that, we also have the wasteland maps which provide some excellent data for you to possibly go for energy. For example, if you want to really go for solar-based energy computation, then here is a data set which allows you to go exactly where you want to put solar farm and things like that. In addition to that, the government uses the wastelands data for setting up industries and things like that also. We use satellite data for regular crop production monitoring. Government uses it for 8 major crops in the country today, and we get information for all the 3 seasons. Could be Rabi season, could be summer season, and also could be Kharif season. And these maps very clearly show you the production of different types of crops. Much before the harvest, the government comes to know what is the production of food grains in the country. This is very, very unique technology which India is using today. On the water, we have an excellent portal. We call it as India Water Portal. The government of India, Ministry of Water Resources, uses it for managing the water resources in the country. Anybody who is interested in understanding the river basin atlases of India, river basin system in India, can download this tool directly. It's like a book. It gives you an excellent information about the entire country's water system. This is an interesting information which I think Madam was talking about just now. We have the surface water body information system. Any water body which is 2.5 hectares and above can be captured from satellite data on a regular basis. Every 15 days we provide this particular data set on the portals, and in fact you can see all the water bodies of Bangalore within the BMRDA range which has been mapped. In fact, you can geotag each one of the water bodies and they can be conserved. We have given a very good system for Telangana and Andhra Pradesh. I don't see a reason why we cannot do it for Karnataka. We can do it for the entire Karnataka, not only Bangalore, and it's pretty easy because as you can see here on the left hand side, every 15 days you literally see the medium irrigation, the small irrigation and the large irrigation tanks that can be monitored easily from space, both with respect to the quantity of water, the volume of water, as well as the release of water for minor irrigation activities also. So that way you can look at small water bodies, you can look at even Hirakud reservoir and its content of water for irrigation. In addition to that, all the water bodies in urban area can be easily monitored on a regular basis. On the groundwater front, we have something called as Bhuvan Bhujal, which provides the entire country's groundwater potential maps, and these can be used very effectively, particularly under dry seasons. We have been using very effectively last 2 years. North Karnataka has been facing very major problems. We are able to go down to the cadastral level and provide information to those people who really need water badly, because there are many boreholes which are going dry and they are not able to really cope up with the requirement of the water. So here are some high resolution maps which shows the capability of using the technology to provide water, particularly for very dry regions. On the biodiversity front, we have mapped the entire country's biodiversity. It is a very rich database what we have. We have 125 different types of vegetation, very unique vegetation which has been mapped. More than 6,000 species database has been created. This has been made available to the Department of Biotechnology. It's a joint project with Department of Biotechnology, which of course uses it not only for biological richness and disturbance regime, it is also being used across the country for conservation and bioprospecting. This is a very unique project which was done for Karnataka. As again Madam was saying, it is not difficult. Even rural areas can be taught how to use satellite data and you can conserve the nature. And we did a very, very interesting successful project as Sujala, which basically provided the watershed development program. From satellite images, we were able to provide them the GIS database for local areas, and the farmers were shown the Rangoli diagram on the ground to exactly find out what are the problems they are facing, and we were able to integrate that data to the satellite data to provide them the local specific information which helps them in understanding the terrain. It could be slopes, it could be soil, it could be land use, it could be geology, geomorphology, etc. They were integrated, and with the participatory method, the villagers were shown and told what to do, and even the development plans with respect to land and water was shown to them, including the understanding of a watershed, which basically talks about rich to valley concept. This helped particularly places like Chitradurga, Haveri, etc. to come back to a much better land use pattern, because they were able to improve upon the land use and land cover. And here is a typical example which shows a very dry area. You can see these marked out places became quite rich in about 7 years time frame. They were able to bring back a lot of vegetation which was completely gully terrain. You can see this here. It was pretty rich, and even foreshore plantations were brought back, which was not to be seen. Even here you can see from the baseline image a very rich forest was grown in about 7 years time frame, and it was sustained. So these kind of action plans can be generated and implemented on the ground. Now, because of such a success, we also have this kind of a project taken up as part of the integrated watershed development program in the country, and presently we are monitoring 86,000 watersheds in the country. I leave that. On the disaster management front, we have been continuously looking at databases from 2013 onwards. As you can see, I have been managing the disaster management support program from the remote sensing area. And we are seeing a typical pattern happening in the country. 2013 is the pattern, 2014, 17, 18. Literally, the northern portion, the eastern portion get affected time and again. So we are trying to find reasons by which we can try to see how you can reduce the disaster. Disaster risk reduction is the particular area of research. Of course, flood is the major disaster which is affecting the country in a big way, in addition to the cyclones which mostly affect the eastern part of the country. So we are very actively looking at these integrated databases to come out with a better disaster risk reduction program in the country. A typical example of what happened to Kerala just a couple of months back, where a very huge amount of flood created a massive problem, and from satellite data we were able to give a big relief, particularly for planning and development. A typical example of how the whole thing played out on our Bhuvan geoportal. On a daily basis, we were able to provide a huge amount of satellite data which helped the local government in relief and rehabilitation. One very good thing which has happened to the country over a period of time using the satellite data is we are able to save a lot of lives. In the sense, lakhs of people are moved out much before the disaster occurs, because we know the predictions exactly, we know the landfall of a particular cyclone, where it exactly is going to happen, and we are able to save lakhs of life time and again. This is one very unique thing which is happening, but the problem is you are not able to really save the infrastructure, that means you really have to rebuild on the infrastructure, but we are able to save lives. A typical example of how we are able to monitor the entire Himalayan river basin. This is another very important ecological need of the country. And we not only look at the glaciers and the snow, but we also look at the glacial lakes and water bodies, which are very important, particularly in the months of June, July and August, because they also get into transboundary disaster conditions, particularly with the kind of activities happening across the border. So we monitor these areas very closely and give information much in advance to the government, so that the government can take necessary measures to avert major disasters that happen. In addition to that, preserving these water bodies, preserving the glaciers and snow becomes equally important for preserving or conserving our ecology. Climate and environment studies are very important. We have a program called as NICES, which helps us in understanding varieties of databases that we have. We don't leave any part of the globe, including the Antarctica and Arctics, because the satellites move from pole to pole. When they go over either in the North Pole or in the South Pole, we are able to study what is the situation of both these places, which are actually very important from the global perspective. In addition to that, the ocean, the atmosphere and the cryosphere, all of these are used systematically to see that we have a very good global databases, particularly to see that the ECVs are well fed into the system. Before I close, I'll just introduce you to a particular geoportal called as Bhuvan. Bhuvan is a national geoportal. Most of these things, what I talked about, is all available in our Bhuvan geoportal, which gives you a 1 meter resolution satellite data for the entire country for multiple times. It gives you all the land use, land cover, agriculture, wastelands, all these databases, what I talked about, including every 15 days water body databases are available on this particular thing. So it's a multi-temporal, multi-sensor based databases, thousands of layers of GIS is available, more than 70-80 mobile applications are there, which geotags large amount of ground data into the system. So we have in situ data, the satellite data, and also the mobile based information all collated into one database system, which is serving the country in a very big way. For example, on this particular database, it is possible for you to see what was Bangalore in '65 and what it is today. It is possible for you to literally see the changes that is happening. You can see this is what the previous one was the 65 data. This is what we made it into in 1999 and in 2007. So you can see gradually how the urbanization has changed, how things have changed, how Bangalore metropolitan region, what is shown, is crossed over a period of time. If you see the next satellite data, you will see a lot more things happening here. For example, the kind of development towards Hosur Road, Electronic City, etc., you can see quite dramatic. This is 2017-18 data. This is just an example of, in 5 years, the kind of growth that can happen to Bangalore can be, has been nicely captured and just animating and showing that. So it's not only just urban sprawl, you can look at the transport management system, the solid waste management system, ecological conservation and also natural resources balance. All these things can be beautifully studied with multi-temporal satellite data which is available on Bhuvan. A typical example of what Bangalore was in 70s versus what it is, the popular Belangur tank, the way it is polluted today, what you can see, these two tanks, there was a beautiful connectivity which could be seen very clearly here. This is the tank bund. The tank bund exists today also, but possibly it has become a road. But you can see the urban development which has taken place on the top of this particular range. So literally, you can see beautiful houses, big buildings have come up, and stream is almost left with no space to flow. So literally, we have blocked the flow. That comes out pretty clearly from this particular satellite image. Of course, this is one sample picture. I can study this for the entire country. So before I close, I would like to just say technology enables better conservation and management strategies. There's urgent need for pragmatic approach to see that we change our conditions, particularly like what Madam said. I would like to repeat from technical data. Yes, there are a lot of changes that's happening, but it is possible for us to work towards making Bangalore better. Thank you.